Hello everyone, welcome to my YouTube channel Know About Embedded Systems. In today's video, we will develop programming for UART using STM32 microcontroller. Already in the theory part I have explained. If you have not watched that video, please watch that. I'll update the link in the description box as well. There are totally three different parts we have to do the programming. So there are three parts. The complete programming is split into three parts. The first part I have already explained. The first part is going to be a GPIO site configuration. The second part is an UART site configuration, and the third part will be your UART transmitter or a receiver part configuration. So totally three complete program is divided into three parts: GPIO part, UART section, and UART transmitter or a receiver section. So like this it is divided. Now let us concentrate only on GPIO side first. So in the GPIO side, I have already written the comments. You can see the first and foremost thing is we have to enable the clock for your port A. So port A clock I have to enable, so that I have already done here. GPIO clock enable. So by enabling bit number 0 of your AHB1 ENR register. First part is done. Now second part I have to do, I have to configure your PA2 and PA3 port pins in alternate function. So in order to do that, I have to use GPIO A followed by, there is a register called as mode R. So mode R is equal to, this is very important, which mode we have to configure. So I'm going to configure an alternate function mode, and for that I'm going to define one macro here. So I'll write alternate function mode. For alternate function mode, the value is 2. Okay. So we have to load alternate function mode as a 2. This is the second thing you should know. And which bit field we have to configure, that we have to check it in our user manual or your reference manual. Okay, so go to your GPIO chapter number. So under this GPIO chapter number, go to the mode register. Here you can see this is a mode register or GPIO mode register. Here you can see mode, alternate function mode is defined as 1010 means it is 2. It's a hexadecimal value is 2. Okay, that's the reason I have created a macro there. Now I have to use PA2 and PA3. So you need to come from the, here it's going to be 0x2, and you need to come from the right side here. This is 0, this is PA0, this is PA1, and this is PA2, and this is your PA3. Okay, so these bits we have to configure. So that means if you see up here, so this bit number 6, 7 and bit number 4 and 5. So bit 4, 5 and bit 6, 7 we have to configure in order to configure your UART in an alternate function mode, PA1, PA2 and PA3 in alternate function. Let us do that. Come back here. So already I have taken alternate function mode. So just look back here, PA 4 and 6. So we have to use 4 and 6. So left shift of 4, and then R with alternate function 6. Okay, so this is we wanted to do. Okay, so complete statement is going to configure your alternate function mode. PA2 and PA3 will be configured as alternate function. Okay, so now the second configuration is also done. Now I will move to the third one. Select relevant alternate function for PA7, PA2 and PA3. So for the UART, I'll define here hash define UART underscore AF7. For UART, alternate function is 7, so I'm going to use that 0x7. Okay, so UART, for UART alternate function 7 I'm going to use. That's why I have defined here. For that I need to use a register called as a GPIO EA. There is a register called as A for 0. Okay, so is equal to, so A for stands for alternate function register. So there are two registers are the alternate function register 0 and 1. I'm going to use alternate function 0, and I have to use for TX and RX functions. I'll go back to datasheet here. Sorry, not datasheet, user manual. I have to go. See here. Yeah. So I have to use these bits. Okay, so these bits we have to use. Bit number 12, bit number 8. Okay, so bit number 8 and bit number 12, bit number 8 and bit number 12 I have to use in order to configure appropriate alternate function. That means this one. So this should go here, and this also should go here in this bit field. That means 8, 7 left shift of 8 and 7 left shift of 12 I have to use in order to configure appropriate alternate function in a AFR register, right? So that's what I'm doing here. AFR 0 is equal to, so I have already taken here alternate function. Bit number 8 and 12 I have to use. Bit number 8 or with bit number 12. So this statement will configure your appropriate alternate function, your PA2 and PA3 in a appropriate alternate function 7. Right. So this is the third important and the final step under GPIO section. So 8 and 12, just I'll confirm. Yeah, 8 and 12, that's fine. The first part GPIO is done. Now I will go to the UART section. In the UART section I need to enable the clock for USART 2. In order to enable clock to the USART, so what I have to use? I have to use RCC, the same register I have to use, but this time I'll be using APB1. I'll be using APB1 ENR. Here you can see this is the register I have to concentrate. So register name RCC APB1 ENR, and here you can see. Okay, bit number 17 I have to use. This bit number 17 I have to use. Okay, so in order to enable the clock, so I'll come back here and I'll create one variable or one macro. I'll create here. USART 2 clock enable, and it's a bit 17 it is. Okay, so I'll be using this one. So this is going to enable clock to your UART or your USART. Okay, so now the second step is also we are completed under UART section, and then load the baud rate value. If you want to load the baud rate value under UART, you should know which register we have to use. You can see here, this is the register what we have to use. The register name called USART2 BRR. USART2 BRR is a baud rate register, and we have to load the value of 138, and the calculation you can see here. So this is the simple calculation. Baud rate divided value is equal to peripheral clock divided by baud rate. 16 megahertz is a peripheral clock, and 1,15,200. This is my desired baud rate level, baud rate value. And when you do the calculation, I will get 138.88, and approximately is 113 equivalent to 139. And I'll be loading this 139 to the baud rate register. So do that. So you can use USART 2. There is a register BRR is equal to 139. This is my important step under UART configuration. And the last step, I need to enable UART transmitter receiver and your UART enable as well. So this can be done under UART control register. Come here. So go to the chapter number 20 of UART. Yeah, here you can see UART registers are there. Here you can see UART control register. So this is a UART control register, and under this I need to enable bit number 2, bit number 3, and then bit number 13. So 2, 3 and 13 I have to enable. Okay, so let us do that. 2, 3 and 13. So you can, if you want, you can create one macro for this as well. So hash define USART underscore enable bit number. For USART it is 13. You can define as a 13 value, and USART TX enable, and then RX enable. Bit number 2 and TX is 3 and RX is 2. Okay, so now like this you can enable. So now I will use a register here, enable. So UART 2 CR1 I have to use USART 2 control register 1 is equal to, so just you can use the macros already what I have declared. So you can use enable, then TX enable, and then RX enable. Okay, so like this easily using macros you can, it will be very easy when you use a macro. No need to remember any bit number and all. You just define the bit number above with a macros, and you can easily use the macros. Okay, so now the two major things we have done, GPIO site configuration is also done, and also the UART site configuration is also done. Now I will move to the data transmission function. Here you can see it's very simple. Data transmission function UART data TX. Okay, now I need to check here UART data register is empty or not. So in order to do that, again I'll go back to UART chapter number 19. Registers you go. Yeah, you can use this one, bit number 7 TX empty. Okay, you can use a bit number 7 TX empty. Right, you need to monitor this in order to check TX empty. So you can come back to coding here and create one macro for that. Hash define TX empty. So bit number 7. Okay, if you want to, you can write like this as well. So UART TX empty, one left shifter 7. So now what you do, you copy this and you can just come here, put it in a polling statement while negation of. So I need to use a register USART 2 status register. I have to use SR, and with the macro value what you have declared here, and if that is the case, just be there. Okay, yeah, so this is a statement in order to check whether your data transmitted completely or not, or whether your UART transmitter is empty or not. Okay, and after this I need to load the data to the data register. So in order to do that, very simple it is. You can just, instead of SR you can use DR. DR stands for data register, and data is nothing but, here you can see, which will be loading from your main function. Yeah, so this much, and you can add a small delay here, around 50 you can add. That's it. So this much I had to do the function call here. You can call the UART configuration, and then you can, You can transmit a character. I'll be transmitting character A here. So we will check whether will it work or not. And after small time, I'll be transmitting ABC with a one space. So no errors. I'll flash it to the microcontroller and let us check whether will it work or not. Okay, now the successfully flashing is done. This is my UART terminal. I'll try to connect here, and I need to select the baud rate 1,15,000 and just connect it. Yeah, now you can see I'm able to receive the character ABC. So this is what I have given the input, right? I have given character ABC in the input, and if you look back to the code as well, you can see the character I have given ABC. So that means my program is working perfectly. There is no doubt. So like this, you can use your microcontroller STM32 and you can develop your own program, and you can transmit from one device to other device. You can transmit your data using our UART protocol. So I hope this video is an informative video. If you have any questions, you can write it in the comment section. I'll try to answer in the comments. So if you feel this video is an informative video, please click on like button and subscribe to my YouTube channel and click on bell icon. Share this videos to your friends and colleagues.